Hello and welcome to Mr. Connally's Math. Today we're doing solving absolute value equations, but before we go any further, be sure to check out this video's info tab below for student and teacher resources such as extra practice worksheets, answer keys, and more. And while you're there, don't forget to like this video and subscribe to the channel to get information about future videos. Key concept: can equations have more than one solution? Well, one thing comes to mind: absolute value. If I take the absolute value of a number and it equals 5, then that means that there's two possibilities. What am I thinking of? Well, since absolute value is the distance from 0, there would be 5, because we go 5 spaces to the right. But technically, we could also go 5 spaces to the left. And that would also give us an answer of 5 if we took the absolute value of it. So because of that, absolute value equations have two possibilities. Okay, and how we find those two possibilities, we'll find out in this video. I like to tell students to think of absolute value equations like a treasure. It's got this little box on the side, and inside is a special equation that we need to solve at the very end. In that equation, we have the absolute value of x equals 5, but then we also have the opposite of that, which should be the opposite of absolute value of x equals 5. And we solve that equation. We would take the opposite of the absolute value of x, and we divide both sides by -1, and we would get x equals -5. So this treasure box has two solutions in it: x equals -5 and x equals 5. Also, we need to remember that absolute value equations cannot be negative, because if you take the absolute value of a number, it has to be positive. So the absolute value of 6, for instance, is not -6. It'd have to be +6. And the absolute value of -3 would not be -3. So because of that, we need to pay attention, because sometimes there may be no solution. But we'll look at that today. Example 1, solve x plus 4 equals 9. The first thing we're going to want to do is isolate the absolute value part. So x plus 4, is it all by itself? Yes, it is. There's nothing around it. There's no pirates trying to steal our treasure. So if we think of our little treasure box right here, it's all good. There's nothing around. So with that, we can do the next part, which is make two equations out of that. Remember, I said it's the absolute value of the number and then the opposite of that. So that means that we're going to do two things. We're going to say the absolute value of x plus 4 equals 9, and then the opposite of x plus 4 equals 9. Okay, and in this one on the right, we're going to have to change it a little bit, and I'll show you how to do a shortcut later. But we're going to divide by -1, and that gives us the absolute value of x plus 4 equals -9. So frankly, we have the same equation, but just with a negative answer. Okay, so now that we've got the treasure by itself, we can actually open up the treasures. So x plus 4 over here equals 9. Oh, that looks terrible. Let's fix that. Okay, and then we now open the treasure, and it's going to be x plus 4 equals 9, and x plus 4 equals -9. We've got our two equations. Okay, now we just solve. So we would subtract 4 from both sides. That gives us x equals 5. And then on the other one, we subtract 4. But this time we're taking it away from -9, and that's going to give us x equals -13. Okay, so we've solved both of the equations. Now the last step we can do is verify our solutions. So we have two answers. And to verify, we'll check to see if it works. Okay, so the original equation is x plus 4 equals 9, and the absolute value of x plus 4 equals 9. We'll just substitute our answers. So we'll put in 5 here, and we'll put in -13 here. That gives us the absolute value of 9 equals 9, which the absolute value of 9 is 9. And so that's true. And then the absolute value of -13 plus 4 is -9, but the absolute value of that is +9. And so we get another true statement. And so now that we've verified the solutions, we've proven that the answers are x equals 5 and x equals negative 13. So you could also write it as a solution set with braces. And so we'll put it in order from least to greatest. Negative 13 and 5. Okay, and those are the steps we had used for that. Let's try another example. So example 2. Solve this one. 5 minus 2x, absolute value of, minus 11 equals 0. So in this case, we're trying to isolate the absolute value. And so we'll close up our treasure so we don't bother it. Okay, now is there anything around the treasure? Yes, there's negative 11. And so negative 11 is like a pirate over there trying to take it away. So we need to eliminate that pirate by adding 11 to both sides, and bam, he's gone. So now we're left with the absolute value of 5 minus 2x equals 11. Okay, and now we can cut to the chase and make our two equations. So we're going to actually open up our treasure chest and bring out the two equations, which are 5 minus 2x equals 11 and 5 minus 2x equals negative 11. Okay, we can do the opposite of and divide by negative 1 like we did on the previous one, or we can just jump to this step. Okay, and now we just solve both equations. So we'll subtract 5 from both sides. We get negative 2x equals 6. Divide by negative 2. We get x equals negative 3. And then we subtract 5 from the other side. And we get negative 2x equals negative 16. And now divide by negative 2. We get x equals 8. Okay, so we've made the two equations. We've solved both of them. And now we need to verify the solutions. So we do the same thing. We plug these answers back into the equation. 5 minus 2x. The absolute value of minus 11 equals 0. And we'd substitute 8 and negative 3 in there. And you'd find that both sides would be equal. And that would verify your solution of x equals negative 3 and x equals 8. All right, so let's try another one. Example 3, 3 minus 2x plus 1, absolute value of equals negative 12. Okay, so again, our first step is we want to isolate the absolute value. So in doing that, we see that there's a 3 minus in front of that. We can just subtract the 3 from both sides. And that cancels. We get the opposite of the absolute value of 2x plus 1 equals negative 15. And now we want to, this is like a negative 1 being multiplied in front of it. So we're going to divide by negative 1. And we get the absolute value of 2x plus 1 equals positive 15. Okay, now we've got the treasure by itself. And we can start making our two equations. So the two equations are going to be 2x plus 1 equals 15. And 2x plus 1 equals negative 15, the opposite. Okay, now it's important that when you're doing this part, that you remember that you remove the absolute value symbols from both. You don't want to change this to 2x, minus 1 or plus 1, or change anything inside of what used to be the absolute value. I've taken away the treasure box, I've opened it up and discarded it, and now I'm solving the equation. So minus 1 from both sides, you get 2x equals 14, and then divide by 2. And you get x equals 7. And same thing, got a little ahead of myself over there. 2x equals negative 16. And then we divide both sides by 2 again. and you get x equals -8. Okay, so then we would just substitute our answer back into the original after we've solved both to verify our solutions. So remember, you put those numbers -8 and 7 back into the original equation, and then you should get both sides equal to verify that it's the answer. If you don't get both sides are equal, then there may be a problem with your sign, or it may be a no solution problem, which we'll get to soon. All right, example 4, we've got -5 times the absolute value of 2x plus 12 equals -30. Again, we want to isolate the absolute value symbol. So this is -5 times this. Now, what you don't want to do, although it's entirely possible, is distribute. Can you distribute a number outside the absolute value? The answer is yes, you can. However, you'll miss this shortcut I'm about to show you that will help you and save you time in finding the answer, especially when it's no solution. Okay, so we could do -5 times 2x plus 12, but I like to think of it as a treasure, which is closed off, and instead we use inverse operations to get rid of it beforehand. So let's divide by -5. And in doing so, we get the absolute value of 2x plus 12 equals 6. Okay, and in doing that, we found that the answer is going to be a positive. We don't have to worry about it being no solution, because typically when we see a -30, that should set off a little alarm in your brain saying, uh-oh, is this going to be a no solution situation, or is it going to be the two solutions problem? Okay, so now we've isolated the absolute value. We see that it's a positive answer at the end, so we can continue. So to make two equations now, we're just going to open up the box and then let out the equation. So it's going to be 2x plus 12 equals 6, and then 2x plus 12 equals -6. It's opposite. Okay, so we'll solve both equations now. So subtract 12 from both sides using the inverse operations. That cancels. You get 2x equals -6. And then divide by 2. And you get x equals -3. And now let's do the other equation. -12 minus 12. You get 2x equals -18. And now we divide by 2. And we get x equals -9. Okay, so we've got two numbers here, x equals -3 and x equals -9. Again, the last step means we'd verify the solutions by plugging them back into the equation where x is to make sure that the left side equals -30 as well as the right side. In doing so, you will find that in this case. And so your answers will be the set of -9 and -3. Okay, remember, this is not a coordinate. These are braces that we're using to show that these numbers are an element of the set of x. So we have two solutions in the case. We put them in order from least to greatest. And that's just another way of showing your answer. The one above it is fine. I mean, if you're my student and you're putting it on a test, I wouldn't mark it wrong or anything. But just know that you could see it a different way in a textbook or online or in any of your practices. Okay, now let's look at the last situation. -4 times the absolute value of x minus 3 equals 20. Solve this equation. So like we said before, first step is we want to isolate the absolute value. So this part, our treasure chest, we don't want to distribute, although you could, but make it easier because this is a nice little shortcut that'll help you if you close it off and do it this way. So -4 times this, we'll do the inverse operation. So we'll divide by -4. And now we've got the absolute value of x minus 3 equals -5. And then now a little alarm should go off in your brain. The absolute value of a number equals a negative. Wait, does that make sense? Can the absolute value of 5 equal -5? It cannot. it would violate the definition of absolute value. So because of that, when you come to this part, you should check your solution. If the solution says it's negative, then that means the answer is no solution. If it was positive, then you could make two equations and do the problems like we did on the previous four. Okay, so we could actually stop here and just say no solution. Okay, and if you don't believe me, you could try and make an equation, x minus 3. So it's no solution because x minus 3 equals negative 5, x minus 3 equals 5. If we were to write this out, we would get x equals plus 3, so minus 2, and x equals 8. And we would think, oh, that's our answer, right? Okay, wrong. If we check our solution, negative 4 times the absolute value of negative 2 minus 3, does this equal 20? And negative 4 times the absolute value of 8 minus 3, does this equal 20? We're going to find out that this is not the case, because watch, negative 4 times the absolute value of negative 5, that would give us negative 4 times positive 5. And does that equal 20? No, negative 20 does not equal 20. That's false. Okay, so because of that, you would get that far. And if you didn't verify your solution at the last step, which some students may forget to do sometimes, you won't even know that there's no solution to this one, and you get the problem wrong on the test. So don't believe me? Check the next one. 8 minus 3 is 5. And the absolute value of 5 is still 5. So negative 4 times 5 is negative 20, which does not equal 20. That is also false. Okay, so that's why this is no solution. So if you don't check your work at the very last step, then you won't know that this is a false answer. You could prevent all this by just making sure that you're vigilant and you remember, oh yeah, on the second step, I should check if the solution is negative. If it is negative, then that means this is going to be no solution. I don't even have to do any more work. However, if you do forget and don't check your answer, you'll miss that part and get that problem wrong on the test. So make sure you're following all the steps so that you can ensure that you get the right answer and all the points on your next assessment. Okay, great job on this last problem. Let's go over the key concept before we conclude. Can equations have more than one solution? As we found in this case, the answer is yes when we're using absolute value equations, because the absolute value of 5 has two answers, 5 and negative 5. And so because of that, we can actually solve the equation by isolating the absolute value first. In the second step, checking if the solution is negative, because that would mean no solution. We can save ourselves time. If it is a positive answer, then we can make two equations, solve them both, and verify the solutions to get our answer. Don't forget to verify at the very end, because that can save you on a no solution situation. And lastly, don't forget the overarching concept that absolute value cannot equal the negative number. Because of that, that means that the absolute value can either have two answers or no solution. So remember what you've learned. If you need anything, please let me know. I'm here to help. Right now, I just want to tell you,
excellent work on completing this tutorial. If you like this video, be sure to give it a big thumbs up and subscribe to Mr. Connally's Math and Mr. Connally's High School Math channel to get updates on future videos. Thanks for watching.
MrConnally.com